Hi guys, this video to practice on the posterior distribution of the population mean. So, as we have done before, I will cover three methods to summarize the posterior distribution of the population mean. The first one is grid approximation. Second one is the exact calculation in our lecture note. The last one is Monte Carlo approximation. It means I will randomly select a sample from the exact posterior distribution and work on the sample. And the estimation from the sample will be almost exactly the same, the exact calculation. Especially if you select a very big sample from the posterior distribution and work on this one. You can work on the sample to do whatever you want. You can estimate the posterior mean, which is the mean of the sample, the posterior variance, which is the variance of the sample. You can calculate the p-value using the sample greater than some value, less than some value, between two values for the population mean. You can do a credible set using the sample, like you can find the 95% quantiles, like 2.5% percentile and 97.5 percentile. So what you do with the exact distribution, you can do with the sample itself. Or you can do the grid approximation, like you select some values for possible values for the population mean, and then evaluate the likelihood at these values, evaluate the prior at these values, multiply the prior by the likelihood, you get something proportional to the posterior probabilities, and then you change them to be probabilities by take the sum and then divide by the sum, and so on. And then you get the posterior probabilities, and then you use the values and the posterior probabilities to do whatever you want, like calculate the posterior mean, posterior mode, posterior standard deviation, and so on. So let me go over these ones. The first method, the grid approximation. The conjugate prior distribution for the population mean is normal. This is the conjugate prior. And the likelihood is a kernel of normal in terms of taus. So tau square is 1 divided by sigma square, and tau 0 square is 1 divided by sigma 0 square. In our motivating example, n is 50, y bar is 0.95, sigma square is 0.05, which is known, mu 0 is 0.99 from previous study, sigma 0 square is 0.03 from previous study. So I run these ones, and then I calculate tau square, tau 0 square, and then I calculate S and calculate sigma, which is square root of sigma square, calculate sigma 0, which is square root of sigma 0 square. Because I need them, because in R we work with the standard deviation, we do not work with variance. And then I will select some values between 0 and 2. Those are the values. So those are the, assuming those are the possible values for the population mean, I will evaluate the likelihood at these values and the priors at these values, and then I will multiply likelihoods by the prior, and then I change them to be probabilities, and I use these posterior probabilities to do whatever I want. So let's evaluate the likelihood, which is approximately, it is a kernel of normal distribution with mean y bar and standard deviation square root of sigma square divided by n, or 1 divided by n tau square at these values. And then I will change them to be probabilities by dividing the likelihood by the sum of the likelihood. And then I will calculate the priors. I will evaluate the prior distribution at these values, calculate the density, and then I will change them to be probabilities. And then I will multiply the likelihoods by the priors, get the posterior probabilities, and I will change them to be probabilities. Those are the posterior is proportional to the multiplication. So the posterior probabilities are this one. And then let me graph the likelihood, prior and posterior. Graph the likelihood. And then I graph the priors. This is the prior distribution. And this is the posterior, the likelihood. And then let's graph the posterior distribution. Looks like almost equal to the prior, the likelihood. Looks like the likelihood dominated the estimation. See, but there are a little bit difference between these two. And this is, I can add some legend for the likelihood, prior, posterior. How do I calculate the posterior mean? Using the formula for the basic probabilities. Like if you remember, you calculate the sum, the formula for the expected value is the sum of x times the probability of x. So the posterior mean is the sum of the values times the posterior probabilities of these values and take the sum. So this is the posterior mean, 0.9512903. It is the same thing that we calculated in our class using the exact calculation. So in our lecture note, we worked with the normal distribution as the data distribution, and we found the likelihood is a kernel of normal distribution, and we assign prior distribution for the population mean normal with mean mu0 and tau square is 1 divided by sigma square. And we found that the posterior mean is normal with mean and variance equal this one. So now we can find the posterior mean, posterior variance, posterior standard deviation, posterior median, posterior mode using the exact posterior distribution. And we can find the 95% credible set using the exact posterior distribution. So this is the formula for the posterior mean, which is equivalent to the posterior median, posterior mode. So it is always the same value. And I calculate the posterior variance using this formula. And then if I would like to print this one, highlight. So this is the posterior variance that we have calculated in our lecture notes. The posterior standard deviation is the square root. So this is the posterior standard deviation. And I use the Q norm to find the 95% credible set. The mean is the posterior mean. The standard deviation is the posterior standard deviation. I calculate the 2.5 percentile and 97.5 percentile for the 95% credible set. This is the lower limit and upper limit of the credible set that we calculated in our class, on our lecture note. Using the Monte Carlo sampling, also it gave me the same estimation and everything. But so I work with a random sample. So let's randomly select a sample of 100,000 of observations from the posterior distributions, the exact posterior distribution. This is the posterior mean, posterior standard deviation, and I ask using R norm to find a random sample to generate a random sample from 100,000 from the exact posterior distribution. And I can use this random sample to calculate the posterior mean. I calculate the posterior standard deviation. I can graph the distribution, the posterior distribution using a histogram and so on. So you can do whatever you want with the random sample you randomly selected from the posterior distribution. All of them gave me the same estimation and the same inference and everything. So please download this file and practice on R. And if you have any question, please let me know. Thank you so much.